see about Cayley Hamilton theorem. The statement of the Cayley Hamilton theorem is every square matrix satisfies its own characteristic equation. That means in the characteristic equation, if you replace lambda by the matrix, then that equation also satisfies. Now we will see the problems based on the Cayley Hamilton theorem. So consider this problem. Verify Cayley Hamilton theorem for this matrix A and hence find A power 4 and A inverse. So for that, first we need to find the characteristic equation of the given matrix. The characteristic equation is of A is determinant of A minus lambda I equal to 0. That is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0, where S1 is sum of main diagonal elements. So that is 2 plus 2 plus 2, 6. S2 is sum of minors of main diagonal elements. So which is equal to sum of the minors of main diagonal elements. That is first find the minor of A11. So determinant of 2 minus 1 minus 1 2 is the minor of A11. Now find the minor of A22. So for that remove the corresponding row and column. Then you get 2 2 1 2, and then find the minor of A33. Then you get 2 minus 1 minus 1 2, and then simplify this, then you may get 8, and S3 is determinant of A. So if you simplify, then you get 3. Therefore the characteristic equation is of A is lambda cube minus S1 lambda, S1 is 6 lambda square plus S2 lambda, S2 is 8 lambda minus 3 equal to 0. This is the characteristic equation by Cayley Hamilton theorem. Cayley Hamilton theorem. Every square matrix satisfies its own characteristic equation. Means in the characteristic equation replace lambda by A. So A cube minus 6 A square plus 8A minus 3I. Replace the constant by the constant into the identity matrix. Then you get the zero matrix. Now we are going to verify this one. So for that, first we need to find this A square and A cube. Because A only we know. After finding A square only, we can substitute. A square is nothing but A into A. So find the product of A with A. Then you can get 7 minus 6, 9. Minus 5, 6, minus 6, 5, minus 5, 7. If you don't know the matrix multiplication, then go through the video of matrix operations. Similarly, find A cube. A cube is either A square into A or A into A square. So then you get 29 minus 28, 28, 38, minus 22, 23, minus 28, and 22 minus 22, 29. Now, if you substitute these values in the equation 1, then what is it? This is equation number 1. So from this, what you may get? A cube minus 6A square plus 8A minus 3I, which is equal to, now substitute the value of A cube. So A cube is this one. a cube minus 6 times a square. A square is this one. Then substitute a value also. So A is this matrix. You substitute plus 8 times A, then minus 3 times I. So I is the identity matrix, also called unit matrix. 3 and then 1 0 0 0 1 0 0 0 1. That is the diagonal matrix whose diagonal entries are equal to 1 and off diagonal entries are 0. Now if you simplify, then you get 0 0 0. So this is the verification. Simplify these matrices, then you get hence verified. Next question is and hence find a power 4 and a inverse. You know, by Cayley Hamilton theorem, we get this equation. So from this, if you substitute, first find from this a cube equal to 6a square plus 8a minus, we are going to take to other side. So it will be minus and here it will be plus 3i. Now, if you multiply a with this equation, everywhere if you multiply a, then we get a power 4 minus 6a cube plus 8a square minus 3a equal to 0. That means a power 4 equal to 6a cube plus 8a square, not 8. We are going to take other side. So it will be minus, then plus 3a. Now, in this, if you substitute a cube as this one, that is 6 times 6a square minus 8a plus 3i, then write the remaining as it is. Now simplify this expression, then you may get 28a square minus 45a plus 18i. Now you substitute the values of a square, a and I, then you get 28. What is a square? A square is this matrix. You substitute this matrix, and then minus 45 times a. Substitute a matrix, and then plus 18 times I matrix. Now if you simplify this matrix, then you get a power 4 value. So here the question is and hence find the a power 4. You should not find a power 4 as a square into a, because the question is and hence find a power 4. That means you have to use the Cayley Hamilton theorem to find the value of a power 4. So after simplification, you will get this answer: 124 minus 123, 162, minus 95, 96, minus 123, 95, minus 95, 124. So you can verify it. It's just a simple expression only. Now we need to find A inverse using the same equation, that is here. In this equation, you multiply by A inverse. So A inverse is possible because we don't have 0 as an eigenvalue here. If 0 is the eigenvalue, then definitely the eigen characteristic equation is lambda cube minus s1 lambda square plus s2 lambda equal to 0. Then only you will get 0 is one of the eigenvalue. But here it is not 0 is the eigenvalue. So matrix inverse is possible. Since the determinant of A is not equal to 0, so matrix inverse is possible. So multiply by A inverse on both sides. Then what you may get? If you pre-multiply by A inverse, then A inverse into A cube is A square, and A inverse into A square is A, and A inverse into A is I, and then A inverse into I is A inverse. So substitute here. A inverse into A cube is A square minus 6A plus 8I minus 3A inverse equal to 0. From this, A inverse equal to 1 by 3 times A square minus 6A plus 8I. Now substitute the values of A square, A and I. Then you get the A inverse matrix, which is equal to 1 by 3 times 3, 0, minus 3, 1, 2, 0, and minus 1, 1, 3. You can verify it. Thank you.